First things first, when we're multiplying mixed numbers, 5.3, we're multiplying mixed numbers. You do not need common denominators. Okay, you do not need common denominators when you're multiplying fractions. Okay? However, when you have a whole number or mixed number, you must convert them to improper fractions before multiplying. Okay, we don't need common denominators. And if you have a whole number or mixed number, you must change it to an improper fraction before multiplying. Now, let me give you an example of that. All right. Let's take, for example, I have 1/3 times 6. Okay. Well, first of all, what is 6 times 1? 6. So is 1/3 less than 1 or greater than 1? 1/3. So if you have 1/3 of the pizza, you have greater than a whole pizza? No. 1/3 and 1, is 1/3 less than 1 or greater than 1? Less. So if 1 times 6 is 6, then 1/3 times 6 is something less than 6. Okay? Doesn't give us the actual number, but it gives us a range of numbers that we have for the answer. Okay? Now, first things first, I have to take 1/3 times 6 over 1. 1/3 times 6 over 1. All right, now, the whole number has been expressed now as an improper fraction. Okay, we took this number and made it 6 over 1. Okay? You must convert them to improper fractions before multiplying. Okay, so Jesse, do you have a question? How did I get the number 6? It's in the problem itself. It's like problem number 15, 16. I just made it up. Yeah, you're on the wrong page. There you go. Yes, Brother Isaiah. Under the whole number, yes. So if you had 10, it would be 10 over 1. If you had 20, 20 over 1. Yeah, always over 1. All right, now, we learned something last year that we called Jimmy Neutron. Okay? Remember, Jimmy Neutron is our catchphrase for cross-canceling. It does. Okay. Now, cross-canceling means this. When we cross-cancel, we are looking for a common factor between 1 and 1 or 6 and 3. Okay, so we're looking for a common factor between the numbers 1 and 1, one top to one bottom, and 6 and 3, the other top, the other top to the other bottom. Okay, now, is there a common factor between 1 and 1, Brandon? 1. But does it help us to divide a number by 1? No. You get the same number. Colton, is there a common factor between 6 and 3? What is that common factor? No, not how many times does 3 go into 6. What's the common factor? 3. Okay? So I can divide both 3 and 6 by 3. So here it was 1, here it was 3. So I take 3 and divide it into 3, it gives me 1. I take 3 and divide it into 6, it gives me 2. Okay? Now, what I have left at this point is I just multiply straight across. So I have 1 times 2 on top, 1 times 1 on bottom, which is 2 over 1, which is 2. Okay, now, let me show you a different way to look at this problem. Okay, what we're basically doing when we cross cancel, okay, let me write the original problem. Okay, what we're doing when we cross cancel is this. We're writing each of the numbers 1, 6, 1, and 3 in their prime factorization. Okay, so I have 1 times 2 times 3 on top, and I have 3 times 1 on bottom. Okay? In other words, this right here represents the 6. This represents the 1. This represents the 3. And this represents that 1. Then I'm just taking and canceling out any of them that are the same. Well, that 3 and that 3 cancel out. And that leaves me with what on top? 1 times 2, right? Okay, so that leaves me with 1 times 2 on top and 1 on bottom. 1 times 2 is 2 over 1, which is equal to 2. No. Okay. 1, what is the prime factorization of 1? 1. Okay. What is the prime factorization of 6? 2 times 3. So this right here is where I got those numbers there. Yeah, you just prime factor them. Because how do we find the greatest common factor of two numbers? We do what? In other words, no, hang on. Let's think about this. Back to chapter 4. If I was trying to find the greatest common factor of 4 and 12, okay, what did we do? We prime factored them. Okay, and then we said, okay, this is 2 times 2, this is 2 times 2 times 3. And then we said, okay, that one's common, that one's common. So the GCF of 4 and 12 would be 4. Now we're taking that information and using it. In other words, here, let me try to think of one real quick. Let's say I had 3 over 4 and times 7 over 12. Now, hang on here. Let's see. I don't want to do it that way. I want to do it this way. 12 over 19. Okay? And so I want a Jimmy Neutron. I want to cross-cancel between 4 and 12. Okay, well, to do that, you would have on top, if you use the prime factorization method, 3 times 2 times 2 times 3. Let me make those X's. Okay, that represents that number. And then on bottom, you would have 2 times 2 times 19. Okay, this 2 times 2 represents that 4. Okay, and now I can just go and cross-cancel. This 2 cancels that 2. This 2 cancels that 2. Well, what is 2 times 2? 4. Okay? So it's the same deal. Okay? And so what you would have left on top is 3 times 3, and on the bottom you'd have 19. And so that would give me 9 over 19. And that would be your answer. I can do the same thing with Jimmy Neutron. Okay? I can say 4 goes into 4 once, 4 goes into 12 3 times. That's what I'm doing. Okay? That's what I'm doing. Whether you understand it that way or whether you understand it this way, these two things are the same. It's just which way is easiest or which way you understand the best is the way that you need to do it. Isaiah?
So are we supposed to go this way or?
No, you always cross-cancel Jimmy Neutron. You go top to bottom, top to bottom. You don't go straight across. We don't ever Jimmy Neutron 3 to 12, 4 to 19. You don't ever cross-cancel that way. That's not crossing. That's vertical. I mean, that's horizontal. Jesse? No, not at all. Next time we'll have a little marker action. Yes, Tayshawn, now that Jesse has quit rudely interrupting us with this snoring. If the answer, yes. Okay, let's say that's a good question. Let's say that the original problem, 1/3 times 6 over 1. Let's say you didn't see that it had common factors, and you multiplied it out. You just said, okay, I'm multiplying. Well, that would give me 6 over 3. Okay, Tayshawn's question was, if it's 6 over 3, do I have to reduce it? Yes, you do. That has to reduce to 2 over 1, which is the 2. So either way, here to reduce it to 2 over 1, you would have divided by 3 over 3, right? Well, what did we divide up here by? Up here we divided by 3. Okay? So either way, you're going to have to divide it by its greatest common factor, either at the first or at the end. The problem you have if you don't do it at the first, then you're probably on some of these going to end up with numbers like 592 over 212. And then you've got to try to reduce that. Okay? And that's obviously harder than reducing, a 6 and a 3. So do it at the first, and it will help you in the long run. Brandon?
How did you get like 3 times 3 on that one?
Down here?
Yeah.
So I have a 3 left there and a 3 left there. So 3 times 3. That's how I got that. Okay? All right, let's look at another one that's got actual mixed numbers in it, not just whole numbers. For example here, 7 1/2 times 4 2/5. Now, here's the other thing I want you to understand, okay? Let's look at this problem. Let's look at the whole numbers in this problem. 7 and 4. What is 7 times 4? 28. Okay? So you've got to have an answer that's over 28. Now, if you get 220, well, that can't be right because this would be 7 times 4. Well, if I increased it by 1 and made it 8 times 5, what is 8 times 5? 40. So your answer has to be, the answer must be, give me back to regular ink, between 28 and 40. If your answer is not between 28 and 40, you've done something wrong. Okay? So that's how you can, when you have the whole numbers, that's one way that you can check to make sure your answer is logical. Now, it's not going to give you the answer, obviously, because I have to do something with the fractions. Okay? But it will at least get you logically where you need to be. The other thing that people do that is totally wrong is they'll come in here and they'll multiply 7 times 4 and get 28 and then take 1/2 times 2/5 and put that fraction with the 28. No, you can't do that. Okay? By our rule, the first thing we must do to this is change them both to improper fractions. So let me rewrite it down here. 7 1/2 times 4 2/5. Okay? 7 1/2, if I'm going to change it to an improper fraction, would be 7 times 2, which is 14. 14 plus 1, which is 15. So that is 15 over 2 times 4 2/5. If I'm going to convert it to an improper fraction, it would be 4 times 5, which is 20, plus 2, which is 22, and that would be 22 over 5. Yes, sir? What about the one on top? Right there. No, the one on top, in other words, I said 7 times 2, which is this, 14 plus 1, which is that. And then you put that number on top. Take the whole number times the denominator and add the numerator to that. So 4 times 5 is what? Plus 2. 22 over 5. That's where I got the 22 over 5. Son, see, you got to write like this, not, like you're some artist throwing crud all over the wall. Because now you're going to go, where did that, what, yeah, and then you're going to go, I can't understand that. What, Tayshawn? Thought you wanted to contribute to my class. Gabby?
Do you always change it into an improper fraction when you're dealing with,
As long as mixed numbers, as long as it's a mixed number. If I would have had this, 7 1/2 times, let's say, 3 over 5. Okay? Well, you only change the 7 1/2 to 15 over 2 times 3 over 5, and you go from there. If one of them is a proper fraction, then you don't change a proper fraction. You can't change a proper fraction to an improper fraction without doing the reciprocal, and then you've got a totally different problem. So
every time there's a whole number beside that, you'll have to multiply and add?
Every time. Yep. Yep.
Multiply the full number by the denominator?
And then add the numerator to it. All right, Jesse. So I can keep you awake back there. Is there a common factor between 2 and 22? What? Is it 2? Yes, it is. So 2 goes into 2 one time. 2 goes into 22 11 times. Now, is there a common factor between 5 and 15? What is the common factor between 5 and 15? Cameron? I guess we're going to have to all stand up. We're all having a little trouble. 5, okay. 5 will go into it. 5 will go into 5 one time. 5 goes into 15 3 times. Now, what I have left is this. 3 times 11 on top, 1 times 1 on bottom. 3 times 11 is 33, and that is 33. What? No, if it was 33 over, let's say it was 33 over 2, you would simply divide 2 into 33. Goes once, bring down your 3, goes 6 times, be 12, remainder 1, take the 1, put it over 2, so that would be 16 1/2 is what that would be. No. I'm just, if instead of getting 33 over 1, instead of getting that, if I got 33 over 2, then you just change the improper fraction back to a mixed number. There will be some that will be like that. Let me see if I can find you one right quick here. All right, 1 1/5. 1 1/5 times 5 1/2. Now, once again, we can estimate by saying 5 times, or 1 times 5, which is 5, and we can say 2 times 6, which is 12. So in other words, the whole numbers like they are there, which would give me the low end of our estimate, and then rounding this up from 5 to 6, rounding the 1 up to 2, 2 times 6 is 12. So my answer must be between 5 and 12. Okay? Now, this one is at a half. Okay? This one's at a fifth, which is not close to half, so it's probably going to be closer to the 5 end than it is the 12 end. Okay? Yes, Isaiah? Where did I get 6? Okay. 1 times 5. Where's the 6 at? I just rounded 5 1/2 to 6. 5 1/2, if I rounded it up, the next whole number would be what? 6. So I'm just saying if I'm giving an estimate. This is just dealing with the estimates, not dealing with the problem. Okay, the actual problem then, I have to take 1 1/5, change it to an improper fraction. So that's 1 times 5, which is equal to 5, plus 1, which is 6, and that would be 6 over 5, times, we have 5 1/2, be 5 times 2, be 10, plus 1 more would be 11, so that would be 11 over 2. Okay? Now I Jimmy Neutron it. Okay, look at the 11 and 5, 6 and 2. We cross cancel here. Is there a common factor between 5 and 11? No, there is not a common factor. So therefore I have to leave them the same. Is there a common factor between 6 and 2? Okay. 2 goes into 2 one time, 2 goes into 6 3 times. So on top, that leaves me a 3 times 11. On bottom, 5 times 1. Now, where people make their biggest mistakes is they'll divide 2 by 2, and they won't mark it out. And then when they go here in a second, they go 5 times 2 instead of 5 times 1. Okay? Make sure when you divide a common factor into both numbers, you mark it out and put the new number. Isaiah. Then we're going to take, yes, that's where we're getting the 3 times 11 and 5 times 1. Yeah. 3 times 11 is 33. 5 times 1 is 5. So now I have an improper fraction that I must change to a mixed number. 5 goes into 33 6 times, be 30. Remainder 3. Put the 3 over the 5. That gives me 6 and 3 over 5. Okay? So what if we have two fractions, 1/8 times 3/4? Okay? Well, is there any mixed number or whole number? No. So there's nothing to change to an improper fraction. So I just look at Jimmy Neutron. 8 and 3, 1 and 4. No. So you just have 1 times 3 on top, 8 times 4 on bottom. Be 3 over 32. And that would be your answer.
So, when I don't understand why we do this one, it ends up like with a whole number, and this one it.
Okay.
End up with like
No. 1/8. Shh. Tristan, sit your head up. 1/8 is less than 1. Okay? 3/4 is less than 1. So 1 times 1 is what? 1. So this has got to be something less than 1. Something less than 1 can't be an improper fraction. If it's an improper fraction, then it's greater than 1. So if I'm taking two numbers that are less than 1, most of the time, not all the time, okay, like I could give you 5/6 and 5/7, okay, or 6/7. That's going to get you real close to 1, but it's still not going to get you to 1, okay? So anytime you have both proper fractions, you're going to end up with a proper fraction most of the time, okay? Just while you want to go ahead and stand up for me, please? All right. Now, your homework. So we still got about 12 minutes left in class. All right. Now, your homework. 5.3, 2 through 33, 48, and 49. Okay? Like I said, we still have about 12 minutes left in class. Go ahead and start working on that. Make sure to write the original problem, show all your work, and then circle your answer in lowest terms. It's a mark, yeah. Lily? You get an extra drop grade. That's what it is. Okay. But if you don't do it, then when it comes to a test, how are you going to do it? Because not giving you the problems off on a test.
I mean, even if we don't do the homework, you're still going to want to do it.
Yes. Even if you do the homework and got them all wrong, you still get a drop grade. Plus, the other thing is I haven't got the count yet, so you got to do your homework. I'm glad, but like I said, I haven't got the official count yet, so that doesn't apply right now. Okay, so get to work. Huh? You don't unless I catch you again nodding off, and then yes, you're gonna have to work standing up.